Good morning, dear students. My name is Ferhan Mazher, and today we are studying the CAIE Cambridge O Levels Mathematics Syllabus D, DMaths 4024. This is the code of the subject, and we are working on the syllabus. And today we are going to talk about a very important concept, which is about the polygons. We will talk about the simple polygons, convex polygons, concave polygons, regular polygons, and we will use the formula sum of the interior angles of a polygon. We will also talk about the sum of the exterior angles of a polygon. We will also talk about the tessellation. The name of the chapter is Triangles, Quadrilaterals, and Polygons. This is chapter number 11 from the book D1. The name of the book is New Syllabus Mathematics 7th edition. It is published by the Oxford University Press. And we are going to attempt the exercise 11C of this chapter. And this exercise is about the polygons. So let's start. And here we go. So the first exercise, this is the first exercise of this chapter, which I am attempting. This is the most important exercise. And this is about the polygons, exercise 11C from the book D1. So exercise 11C, question number 1, he says, find the sum of the interior angles of each of the following polygons. Polygons are the polygons means figure who has multiple means more than two sides. It has 3 sides, 4 sides, 5 sides, 6 sides, 7 sides. And in this exercise, we are going to talk about the questions. All the questions, they will be about the convex polygons. The convex polygons are those polygons whose each interior angle is less than 180. We call them convex polygons. So in our syllabus, we have convex polygons. So the sum of the interior angles of each of the following polygons. If you know the number of sides of a polygon, you can find out the interior angle, sum of the interior angle. The formula is the sum of interior angle is equals to 180 bracket start n minus 2 bracket close. So very simple formula. Just remember this formula. First one is 11 gons, 12 gons, 15 gons, 20 gons. 20 gons means there are 20 sides. 15 gon means there are 15 sides. 12 gons means there are 12 sides, and 11 gon means there are 11 sides. So the first question, the first part is showing up. If the n is 11, n11 means there are 11 sides in that polygon. The sum of the interior angles is question. The formula for the sum of the interior angles is 180 bracket n minus 2 bracket close. So in the place of n, I will put 11. So it will be 180 bracket 11 minus 2 bracket close. It will be 180 into 9, and that will be 1620. 1620 degree will be the sum of the internal angles of a polygon who has 11 sides. So the next thing coming up on your screen, B part, and here we have, there are 12 sides, 12 gone. So sum of the interior angles. So the formula for the sum of the interior angles is 180 bracket n minus 2 bracket close. So in the place of n, I will put 12. So it will be 180 bracket 12 minus 2 bracket close. So it will be 180 into 10, and that will be 1800. So sum of the internal angles of a 12-sided polygon will be 1800. So we are going to the next question. The next question is question number 1. It's C part. Here the n is 15, means the polygon has 15 sides. So sum of the internal angles is question. The sum of the internal angles will be equals to 180 bracket n minus 2 bracket close. So 180 in the place of n, I will substitute 15. So it will be 180 bracket 15 minus 2 bracket close. So it will be 180 into 13. That will be 2340. So this is how you will find the internal angle, the sum of the internal angles of the 15-sided polygon. Okay, so the next question, the question number 1 is D part, n is equals to 20. So sum of the internal angles will be equals to 180 bracket n minus 2 bracket close. In the place of n, I will substitute 20 because this polygon has 20 sides. So 180 bracket 20 minus 2 bracket close. So it will be 180 into 18. So that will be 3240 degrees. So the sum of the internal angles of the 20-sided polygon will be 3240. So this was the question number 1. So now we are going to the next question. Here in the question number 2, let me increase the size so you can see it more clearly. Question number 2, and it's A part. The question is, find the value of the unknown in each of the following figures. So the first figure is a four-sided polygon. We call it quadrilateral, four-sided polygon. So one angle is 110, the other is A, the other is 62, the fourth one is 78. So we know that the sum of the internal angles of a quadrilateral. Okay, so this is question number 2, A part. Sum of the internal angles of a four-sided figure will be 180 bracket n minus 2 bracket close. So it will be A plus 110 plus 78 plus 62 equals to 180 bracket 4 minus 2 bracket close. So 4 minus 2, it will be 2. 2 multiply 180, that will be 360. So 110 plus 78 plus 62, that will be 250. So A plus 250 is equal to 360. So A will be 360 minus 250 and A will be 110. So this is how you will do question number 2. It's A part. Question number 2, B part. This is also a quadrilateral, a four-sided polygon. And the internal angles are 84, 2B, 78, and B. So let's see question number 2, and it's B part. So here we have. Sum of the internal angles of a quadrilateral will be 180 bracket n minus 2. So it will be 180 bracket 4 minus 2. So it will be 180 into 2, and that will be 360. The sum of the quadrilateral, the internal angles of the quadrilateral, that will be 360. So 84 plus 2b plus b plus 78 is equals to 360. So 84 and if you add 84 and 78, that will be 162. So 2b plus b, that will be 3b. So 3b plus 162 equals to 360. So 3b will be equals to 360 minus 162. And the 3b will be equals to 198, and b will be equals to 198 divided by 3. So the angle b will be 66. So the angle B will be 66. So this angle B is how much? 66. So now we are going to the question number 2. It's a C part. Here we have 1, 2, 3, 4, 5. It's a five-sided polygon. So it's a pentagon. So in the pentagon, the sides are 5. So there are 5 internal angles. And we will find out how much is the sum of the internal angles. So here we have 101, 2C, 38, 152, and C. Okay, so this is the next question. So here we have this pentagon, the sum of the, this is the question number 2 is C part, and here we go. The sum of the internal angles is equals to 180 bracket n minus 2. So C plus 101 plus 2C plus 38 plus 152 is equals to 180 bracket 5 minus 2. So it will be 180 into 3, so that will be 540. So the sum of the internal angles of a pentagon is 540. So you will have 3C plus 291 equals to 540. So 3C will be equals to 540 minus 291. So 3C will be equals to 249, and C will be equals to 249 divided by 3. So that will be 83. So this is how you will you are going to attempt this question, and that was the question number 2, and it's C part. Let me show you the whole question. So question number 2, its C part is showing up on your screen. So question number 2, its D part is showing up on your screen, and you can see it's a 1, 2, 3, 4, 5, 6, six-sided figure. It's a hexagon, and 108, 4D, 4D, 5D, 102, and 4D. So these are the internal angles of a hexagon. And first of all, I will try to find out what is the sum of the internal angles of a hexagon. Hexagon means six-sided polygon. So here we go. So we have this hexagon. So sum of the internal angles will be equals to 180 and bracket n minus 2 bracket close. So it will be 180 bracket 6 minus 2, and that will be 180 into 4. So that will be 720. So the sum of the internal angles of a hexagon is 720. So it will be 4D plus 102 plus 5D plus 4D plus 4D plus 108 equals to 720, sorry. And so it will be 17D plus 210 equals to 720. So 17D will be equals to 720 minus 210. So D will be equals to 510 divided by 17. 510 divided by 17. So D will be equals to 30. D will be equals to 30. So this is how you will do question number 2. It's D part. So we are going to the next question. The next question coming up on your screen is question number 3. He says find, and very simple, he says find. Okay. So the question is find the sum of the interior angles of a regular hexagon. So we want to find out the sum of the regular hexagon. So method is very simple. So the sum of the internal angles n is 6. So it will be 180 bracket n minus 2 bracket close. So 180 bracket 6 minus 2 bracket close. So 180 into 4, that will be 720. So the sum of the internal angles of a hexagon is, hence find the size of each interior angle of a regular hexagon. So when I say regular hexagon, the regular hexagon means all the 6 sides, they are equal to each other, and also all the 6 interior angles, they are also equal to each other. In the case of a regular polygon, the single internal angle will be equal to, because all the internal angles will be equal to each other. So the internal angle will be equal to 180 bracket n minus 2 bracket close, and whole thing divided by n. Simply put the value, so it will be 180 bracket 6 minus 2 bracket close divided by 6. So it will be 180 into 4 divided by 6, and that will be 120. So the each internal angle of a regular hexagon is 120. And regular hexagon means a hexagon whose all sides are equal and all the interior angles are also equal to each other. So then this says B part, find the sum of the interior angles of a regular polygon with 18 sides. Okay, very easy. The formula is very simple. The n is 18, so the sum of the internal angles of 18-sided polygon will be equals to 180 bracket n minus 2 bracket close. So it will be 180 bracket 18 minus 2 bracket close, and it will be 180 into 16, and that will be 2880 degrees. Then in the B second part, they ask us to find, hence find the size of each of the interior angle of a regular polygon with 18 sides. Okay, so we want to find out the internal angle, and that will be equals to 180 bracket n minus 2 bracket close divided by n. Because it's a regular 18-sided polygon, so all its sides will be equal to each other. That's why they are using the word regular polygon, and all the internal angles will be equal to each other. So we can find the internal angle, a single internal angle, by this formula. So it will be 180 bracket 18 minus 2 bracket close divided by 18. So it will be 180 and into 16 into divided by 18, and that will be 160. So the each interior angle of a 18-sided regular polygon is 160 degrees. So that was the question number 3. Now we are going to the question number 4. He says, by finding the size of each exterior angle of a regular polygon with 24 sides, calculate the size of the each interior angle of the polygon. Okay. So no matter what is the shape of the polygon, and the sum of the external angles is always 360. Remember that. No matter what is the shape, it's a pentagon, it's a hexagon, it's a octagon, the sum of the external angles is always 360. So if the 240 side, 24 sided polygon, it's a regular polygon, so all its exterior angles, they will be equal to each other. So it's a regular polygon, so all the external angles are equal to each other. So we can find a single external angle by the formula 360 divided by n. That's a famous formula, don't forget this. External angle will be equal to 360 divided by 24. So it will be equals to 15. So the external angle is equals to 15. Now, the external angle and the adjacent internal angle. So external angle and the adjacent internal angle, their sum is always equals to 180. So internal angle plus the external angle who are adjacent to each other, their sum is equals to 180. And internal angle plus external angle is 15, so equals to 180. So internal angle will be equals to 180 minus 15, and that will be 165. 165. So this is question number 4, and it's A part. Question number 4 is B part. He says by finding the size of each exterior angle of a regular polygon with 36 sides, calculate the size of each of the interior angle of the polygon. So it's a very important step, very important strategy. So the polygon is a regular polygon. It has 36 sides. When I say regular polygon, all its sides are equal to each other. All its interior angles are equal to each other. All its exterior angles are equal to each other. And I told you that no matter what is the shape of the polygon, and the sum of the external angles is always 360. And so the one single external angle can be found in the case of regular polygon. The formula is 360 divided by n. So external angle will be equal to 360 divided by 36. So it will be 10 degrees. So the each exterior angle will be of 10 degrees. Now, the adjacent external and the internal angle, their sum is equal to 180. Internal angle plus the external angle. In the case of a regular polygon, whose adjacent internal and external angle, their sum is 180. They are supplementary to each other. So the internal angle plus 10 is equals to 180. So internal angle will be equals to 180 minus 10. And the internal angle will be equals to 170 degree. So this is question number 4. It's B part. I hope you understand. So from the exercise 11C from the book D1, New Syllabus Mathematics 7th edition, published by the Oxford University Press, we are on the question number 5. It says, find the number of sides of a regular polygon if each external angle of the polygon is 90, A part, 45, and 12, and 4. Okay. So here the external angle is given, and when the external angle is given, and we want to find out the number of sides. And you know that the sum of the external angles, no matter what is the shape, is always 360. And if in the case of a regular polygon, the single external angle will be equal to 360 divided by n. So n is the question. So the external angle is so n will be equal to 360 divided by the external angle. So n will be equal to 360 divided by 90, and that n will be 4. So if all the exterior angles are of 90, this is a quadrilateral. It's a regular quadrilateral. B part is if the external angle is of the 45 degrees. Okay. So the external angle is 45. Number of sides is question. The external angle for a regular polygon is 360 divided by n. So n will be equals to 360 divided by the external angle. So n will be equals to 360 divided by 45, and that will be 8. So it's an 8-sided polygon. Now in the C part, he says the external angle is equals to 12 degree. How many are the sides? External angle is equals to 360 divided by n. So n will be equals to 360 divided by external angle. So the n will be equals to 360 divided by 12. So it will be 30. So there are 30 sides. Question number 5, it's D part. He says the external angle is 4 degrees. You know the external angle is equals to 360 divided by n. So n will be equals to 360 divided by the external angle. So n will be equals to 360 divided by 4, and n will be equals to 90. So it's a polygon who has 90 sides. Okay, my dear students, from the exercise 11C from the book D1, New Syllabus Mathematics 7th edition, we are on the question number 6. Find the number of sides of a regular polygon if each interior angle of the polygon is 140 degree. B part is 162 degree. Here the interior angle is given 172 degree or 175 degree. So A, B, C, D part. Okay, question number 6. Very simple, straightforward question. He says that the n is question, the number of sides, when the internal angle is equals to 140. You know the formula for the internal angle is 180 bracket n minus 2 bracket close divided by n. So the internal angle is 140. So it will be equals to 180 n minus 360, and the whole thing divided by n. So cross multiplier, so it will be 140 n equals to 180 n minus 360. So bring the n terms on the same side. So I will have 140n minus 180n equals to minus 360. So minus 40n will be equals to minus 360. Minus minus will be cancelled with each other. So n will be equals to 360 divided by 40. So n will be equals to 9. So question number 6, and its B part, the internal angle of a regular polygon is 162. How many sides are there? So the formula for the internal angle, a single internal angle, is 180 bracket start n minus 2 bracket close divided by n. So internal angle is 162, so it will be 162 equals to 180 n minus 360 divided by n, the whole thing divided by n. So it cross multiplies, so 162 n equals to 180 n minus 360. So bring the terms which have n in them on the same side. So we will have 162n minus 180n equals to minus 360. So minus 18n is equals to minus 360. So n will be equals to 360 divided by 18. So n will be equals to 20 sides, means this polygon has 20 sides. So that was the question number 6, is B part. Question number 6, its C part, the interior angle is 172 degree, and we want to find out the number of the sides. So the internal angle is 172, the n is question, n means the number of sides of the polygon. So the internal angle is equals to 180 bracket n minus 2 bracket close divided by n. Substitute n, we want to find out the value of the n. So internal angle is 172. So you will have 172 equals to 180 n minus 360 divided by n. Cross multiply here. So you will have 172n equals to 180n minus 360. Bring the terms which have n in them on the same side. So you will have 172n minus 180n equals to minus 360. So minus 8n equals to minus 360. So n minus minus will be cancelled. So n will be equals to 360 divided by 8. So the n will be 45. So this polygon who has internal angle 172 degree is polygon. This polygon has 45 sides. So the D part is question number 6. It's D part. We have internal angle is equals to 175. N is equals to question. So the internal angle will be equals to 180 bracket n minus 2 divided by n. The internal angle is 175. So you will have 175 equals to 180 n minus 360 divided by n. Cross multiply. So you will have 175 n equals to 180 n minus 360. Bring the terms which have n in them on the same side. So you will have 175n minus 180n equals to minus 360. So minus 5n is equals to minus 360. Minus minus will be cancelled. So the n will be equals to 5n will be equals to 360. So n will be equals to 360 divided by 5, and n will be equals to 72. So this polygon has 72 sides. Now we are going to the next question. The next question is question number 7 from the exercise 11C from the book D1, New Syllabus Mathematics 7th edition. If the sizes of the interior angles of a pentagon are 2x, it's a pentagon. Pentagon means a 5-sided polygon, and its 5 internal angles are given here. He says 2x, 3x, 4x, 5x, and 6x. Find the largest interior angle of the pentagon. Very simple, straightforward question. So n is equals to 5 because the pentagon, so sum of the internal angles is equals to 180 bracket n minus 2 bracket close. So because it's a 5-sided figure, so in the place of n I will put 5. So it will be 180 bracket 5 minus 2 bracket close. So it will be 180 into 3, so that will be 340. Sorry, 540. Now 2x plus 3x plus 4x plus 5x plus 6x will be equals to 540. So the 20x will be equals to 540. So x will be equals to 540 divided by 20. So x will be 27. So the x value is 27. So the largest internal angle is 6x. So 6 into 27, and that will be 162. 162. That's the largest internal angle. Now we are going to the next question. The next question coming up on your screen is question number 8, and he says the exterior angles of a triangle are 3y, 4y, and 5y. Find the value of the y. You know that any shape, it's a triangle, it's a parallelogram, it's a kite, it's a rhombus, it's a square, whatever may be the shape. The sum of the external angles is always 360. So these are the three external angles given. We will add them up and we will make them equals to 360. So here we go. Question number 8 is A part. The sum of the external angles is always 360. So the three external angles are given. So 3y plus 4y plus 5y equals to 360. So 12y equals to 360. So y will be equals to 360 divided by 12. So the y will be equals to 30. Now their question is question number 8. That was the first part. Now question number 8 is second part. Find the smallest interior angle of the triangle. Okay. So the external angles, the angles given, they are external angles. So I want the smallest interior angle. And remember, the smallest interior angle is adjacent to the largest exterior angle. So first of all, I will find out the largest exterior angle of this triangle, and that will be 5y. So 5 into 30, that will be 150. So that's the largest external angle. And to the largest external angle, adjacent to the largest external angle, you will have the smallest internal angle. And you know the adjacent external and the internal angle, and their sum is equals to 180. So the internal angle plus the external angle will be equals to 180. So the internal angle will be plus the 150 equals to 180. So the internal angle will be equals to 180 minus 150, and the internal angle will be 30 degree. So now we are going to the next question. The next question coming up on your screen is question number 9. It's intermediate level. Exercise is 11C from the book D1, New Syllabus Mathematics 7th edition. He says 3 of the exterior angles of an n-sided polygons are 15, 25, and 70. And the remaining exterior angles are 50 degree each. Find the value of the n. You know, it's an n-sided polygon, so it will have n external angles. So the 3 of them are 15, 25, and 70. So the remaining external angles will be n minus 3. And each of them is of 50 degree. And we know that the sum of the external angles, no matter what is the shape of the polygon, is always 360. So we have external angles 15, 25, 70, and the rest of the internal angles, external angles will be n minus 3, and each of them is of 50 degree. We know that the sum of the external angles is always 360. So 15 plus 25 plus 70 plus 50 into n minus 3 bracket close is equals to 360. So you will have 110 plus 50n minus 150 equals to 360. So 50n minus 40 is equals to 360. So 50n is equals to 360 plus 40. So 50n is equals to 400. So n will be equals to 400 divided by 50. So n will be equals to 8. So this has 8 sides. So this is question number 9 showing up on your screen. I hope you understand this. Now we are going to the next question. The next question is question number 10. He says 3 of the exterior angles of an n-sided polygon are 50 each. So the 3 angles are 50, 50, 50. Okay. So these are external angles. 2 of its interior angles are 127 and 137. Okay. And the remaining we know the interior angles 127, 137. So from them, I can very easily find their adjacent external angle. So I know 2 further external angles, and the remaining interior angles are 173. So the remaining angles will be interior angles, will be 173 each. So the internal angles are given. Okay, it's very important. Some angles are external, some angles are interior. So very, very tricky thing. So the external angle is equals to 50. So the internal angle plus the external angle is equals to 180. So internal angle will be equals to plus 50 equals to 180. So the internal angle will be equals to 180 minus 50. So the internal angle will be 130. So he said there are three internal angles, 130, 130, 130, plus the 127 plus 135 plus 173 into n minus 5 bracket close. And the sum of the internal angles will be equals to 180 bracket n minus 2 bracket close. So it will be 652 plus 173 n minus 865 is equals to 180 n minus 360. So it will be 173 n minus 213 equals to 180 n minus 360. So it will be 173 minus 180 n equals to minus 360 plus 213. So minus 7n will be equals to minus 147. Minus minus will be cancelled. So n will be equals to 147 divided by 7. And the n will be 21. So this is how you will do this question. So let me show you this whole. Let me reduce the size so you can see for. Okay, so these lines which you are watching on my slide, I just wrote the exercise and put the papers on a table, and my son Ferhan Mazher, who is just 2 years old, and he likes to make lines on the papers. So he took these papers and made these lines. So hopefully you understand this is how you will do the question number 10, and we are going to the next question. The next question is question number 11. He says A, B, C, D, E, F, G is a regular heptagon. Heptagon means there are 7 sides. If AB and DC are produced and to meet at H, find the value of the BHC. Okay, very simple, straightforward question. Let me show you how this is done. I have made the diagram as well. So here they say it's an n-sided figure. It's a regular heptagon. When it's a regular heptagon, all the internal angles, they are equal to each other. I have tried to make a diagram here to make the things easier. So here I have first of all found what is the internal angle of this regular heptagon. So it will be 180 into bracket n minus 2 bracket close divided by n. So the internal angle will be equals to 180 bracket 7 minus 2, the whole thing divided by 7. So it will be 128.57. So these internal angles, the A, B, C, D, they are the sides and the vertices of that regular heptagon. So this angle at the ABC angle, that is 128.57. BCD angle, that is also 128.57. So if I prolong this AB line and I prolong this DC line, so they will intersect each other at the point H. So because this is a straight line, so the alpha plus the 128.57, their sum will be equals to 180 because it's a straight line. So I can find out the value of the alpha very easily. Same I can do here. So this angle is also alpha. Once I know alpha and alpha, I will be able to tell you what is the value of the BHC because it will be a triangle. So the sum of the alpha plus the BHC will be equals to 180. So the external angle plus the internal angle is equals to 180. So the external angle plus the 128.57 will be equals to 180. So the external angle will be equals to 180 minus 128.57. The external angle will be equals to 51.43. Now that triangle is an isotriangle because both these angles are alpha alpha. So the BHC plus alpha will be equals to 180. So the BHC plus 51.43 plus 51.43 equals to 180. So the BHC will be equals to 102.86 equals to 180. So the BHC will be equals to 180 minus 102.86. So the BHC will be 77.14. So this is how you will find the BHC angle. So hopefully you understand this question. So let me reduce the size. You might be able to see this. So the question number 11, the whole question is showing up on your screen. You can pause the video. You can take your time with this question. Question number 12 from the exercise 11C from the book D1 is showing up on your screen. The point A, B, C, and D are consecutive vertices of a regular polygon with 20 sides. Find the first part is ABC, that's the internal angle. And then he want me to find out the ABD angle. Let me show you, I've drawn the diagram. From the diagram, you will be easily able to understand these wordings. So we are going to the next question. The next question coming up on your screen is question number 12. So let's suppose that A, B, B, C, C, D, these are the sides of that 20-sided polygon. First of all, I will find out what is the angle ABC. That's the internal angle. So because a regular polygon, so the internal angle will be equals to 180 bracket n minus 2 bracket close divided by n. So the internal angle will be equals to 180 bracket 20 minus 2 bracket close divided by 20. So it will be, the internal angle will be of 162 degrees. So this ABC angle is 162. Now I want to find out this CBD angle. So you can see that I have joined the B and the D with each other. And so because the BC and the CD, they are equal to each other. So it's an isotriangle. So these angles are alpha, and this is the internal angle. Interior angle of the polygon, that is 162. So I can find out alpha plus 162 is equals to 180. So 2 alpha is equals to 180 minus 162. So the 2 alpha will be equals to 18. So the alpha will be equals to 18 divided by 2, and that will be 9. Now I know the alpha. I want the value of the AB. Actual question is, what is the value of the ABD? The ABD will be equals to ABC angle minus the alpha. So ABD angle will be internal angle minus alpha. So it will be 162 minus 9, and that will be 153. So this is how you do the question number 12. I hope you understand this. So the whole question number 12 is showing up on your screen from the exercise 11C D1, new syllabus mathematics 7th edition. In the figure, A, B, C, D, E, A, B, C, D, E is a regular pentagon, 5-sided figure, and A, B, P, Q, R, S is a regular hexagon. X is the center of the hexagon. Fine. Their first question is fine. ABP. ABP. That's the internal angle of the hexagon. So very simple. The ABP is basically, ABP is equals to the internal angle of the hexagon. So it will be 180 bracket n minus 2 bracket close divided by n. So it will be 180 bracket 6 minus 2 bracket close divided by 6. So it will be 120 degrees. So the ABP angle will be 120 degree. Their next question is find the PQX. So they want PQX. So this angle AQR is 120. The PQX, because this line will bisect that angle PQR, which is of 120 degrees. So the PQX will be half of the 120. So you can see the PQX is equals to the PQR divided by 2. And the PQX will be equals to 120 divided by 2. So the PQX will be equals to 60 degrees. So this is how you find the PQX. The next question is find the AXB. AXB, you know, this side, and this side. These three sides are equal to each other. So this is an equilateral triangle. The ABX is an equilateral triangle. So each is interior angle is equals to 60 degrees. So the third part AXB, because the ABX is an equilateral triangle. So the AXB will be equals to 60 degrees. ABC, they want to find out the ABC. That's the interior angle. ABC is the interior angle of a regular pentagon. So the ABC will be equals to, because this is the internal angle of the regular pentagon, it will be equals to 180 bracket n minus 2 bracket close. and the divided by n, so it will be 180 bracket 5 minus 2 bracket close divided by 5. So it will be 180 into 3 divided by 5, and that will be 108 degrees. 108 degrees. Now they want me to find out ACD. They want ACD. So if I will join A and C with each other. So the ABC will be an equilateral triangle. So let me show you. Here we go. So if I join A and the C with each other, so the ABC will be equilateral triangle. So I said equilateral triangle. No, it will be an isotriangle. Sorry, because the AB side and the BC side, they will be equal to each other. The interior angle at the ABC is 108. So the angle BAC will be alpha, BCA will be also alpha. So you will have alpha plus 108 equals to 180. So 2 alpha plus 108 will be equals to 180. So 2 alpha will be equals to 180 minus 108. So the 2 alpha will be equals to 72. So the alpha will be 72 divided by 2. So the alpha will be 36. So this angle alpha is how much? 36. Next, the question is ACD. So this ACD, this BCD is the interior angle of this polygon, and its value is 108. So from that, if I subtract the alpha, the remaining will be ACD. So the ACD will be equals to 108 minus the alpha, 108 minus the 36, and that will be 72 degrees. So this is how the question number 13 and its fourth part is done. Okay, now fifth part is ACD. So we have found that value. The next part is sixth part. He wants us to find out the value of the ASE. So ASE is also very simple. If you join S and E, it will be polygon, and we can very easily find out. ASE is question. So join S and E, as you can see from the figure. So because these two sides, the SA and the SE, EA, they are equal to each other, so it will be an isotriangle. So this angle will be gamma, this angle will be also gamma. Let me say this angle is beta. I know this angle BAE, that's 108. I know the BAS, that is 120. So I can find out this beta angle. The beta angle will be equals to 180, beta plus 120 plus 108 equals to 360. So the beta will be equals to 360 minus 228. So the beta will be equals to 132. 132. Now you want to find out this gamma value. So the gamma plus the beta will be equals to 180. So 2 gamma plus 132 will be equals to 180. So 2 gamma is equals to 180 minus 132. So 2 gamma will be equals to 48 divided by 2, and that will be 24. So the ASE will be 224. So I think question number 13 is done. So we are going to the next question. The next question coming up on your screen is question number 14. In the figure, A, B, C, D, E is part of an n-sided regular polygon. The ratio of an interior angle to an exterior angle of this polygon is 5:1. So find the value of the n. Very simple. The ratio of the interior angle and exterior angle is given. So very straightforward, simple question. Okay. So the n-sided regular polygon, the internal angle ratio, the external angle is 5:1. So multiply both the sides with the 5. So you will have 5x ratio 1x. So 5x ratio, 5x plus 1x will be equals to 180, because the sum of the internal angle and the adjacent external angle is equals to 180. So you will have 5x plus 1x equals to 180. So 6x is equals to 180. So x will be equals to 180 divided by 6, and that will be 30. So the value of the x is 30. Now, next thing they are asking is internal angles will be equals to 5x, and that will be 5 into 30, and that will be 150. and the external angle is equals to 1x, so it will be 1 into 30, so that will be 30 degrees. So that is how you do question number 14. Now in the question number 14, he asked us to find the value of the n, so we have found the value of the n. So it's a 12-sided polygon. Then the question is find the ACD. ACD. ACD is this angle. AB and BC, they are the ABC, that's an isotriangle, so very easily I can find out. So the ABC is an isotriangle, so the angle at the BAC and the BCA, they both are alpha alpha, and the angle B is 150, ABC is 150. So alpha plus 150 will be equals to 180. So 2 alpha will be equals to 180 minus 150. So the alpha will be equals to 30 divided by 2. So the angle alpha will be 15. Now you want to find out the ACD side. So the ACD side will be the BCD angle minus the alpha, and you will get the value. So the ACD plus the alpha will be equals to 150, and the ACD plus 15 is equals to 150. So the ACD equals to 150 minus 15, and the ACD will be 35. So the ACD angle will be 35, 135. Okay, now they want us to find out the ADE. They want this angle, ADE. Okay. BCD plus the ADC equals to 180. This is a light angle. So 150 plus ADC equals to 180. So the ADC will be equals to 180 minus 150. And the ADC angle will be 30. ADC plus ADE plus external angle is equals to 180. So 30 plus the ADE plus 30 equals to 180. So ADE angle will be equals to 180 minus 60. So the ADE will be 120. Okay, so now we are going to the next question. The next question is 15. He says, in the figure, A, B, C, D, E, F is part of an n-sided regular polygon. Each exterior angle of this polygon is 36. So because I know the external angles, so I can find the internal angle. This is the regular polygon. So very easily we can find the internal angle. The first question is find the value of the n. And we know the external angle, that is 36. So I know that the external angle in the case of a regular polygon, external angle is equal to 360 divided by n. So n 360. External angle is also 360. So the 360 equals to 360 divided by n. So the n will be 360 divided by 36. And that will be 10. So n, there are 10 sides. B, D, E. So BCD is an isotriangle. BCD is an isotriangle. Very simple. Let me see. BDE. Okay. They want me to find out this angle. Okay. So the internal angle is equals to 180 bracket 10 minus 2 bracket 4 divided by 10. So internal angle will be 144. So the BC in the triangle BCD is an isotriangle. So we will have alpha plus 144 equals to 180. So 2 alpha will be equals to 180 minus 144. So 2 alpha will be equals to 36. So alpha will be equals to 36 divided by 2. So the alpha will be equals to 18. So the BDE, BDE, BDE will be equals to 144 minus 18, and that will be 126. Now, question number 15, this last part is CXD. CXD. Okay, so So the CXD will be alpha plus alpha equals to 180. So CXD will be plus 18 equals to 180. So the CXD will be equals to 180 minus 36. So the CXD will be 144. So this is question number 15. For that was question number 14. So we are basically on question number 15. You can pause the video and you can take your time with this question. CXD. Okay. So we are on the question number 16. He says in the figure, the ACJL, BCEF, DEGH, and IGJK are straight lines. Find the sum of the A, B, C, D, E, F, G, H. Okay, the strategy is very, very simple. Okay, so this is the external angle of this, this is the external angle. So how much will be, this angle? This angle will be how much? It will be A plus B. How much will be this angle? This will be C plus D. How much will be this angle? This will be H plus G. This is how much? It will be E plus F. Okay, very simple. So try to understand. This angle here, this angle will be A plus B. This angle here, this angle will be C plus D. And this angle here, this angle will be H plus G. And this angle here, this will be E plus F. Okay, not these angles, which I shaded. These are not C plus D. This is not A plus B. This angle is, and this angle is also. And the sum of the external angles is always 360. So try to understand. This angle where the cursor is A plus B. This angle where the cursor is, this is A plus B. This angle here is C plus D. This angle here is C plus D. That where the cursor is, this angle is E plus F. This angle where the cursor is right now, this is E plus F. This is G plus H, and this angle is G plus H. You can see this shape here. This is a quadrilateral. And if I add all the 4 external angles of this, exterior angles of this quadrilateral, their sum will be how much? Their sum will be 360. So it will be A plus B plus C plus D plus E plus F plus G plus H equals to 360. So this is how you prove it. So if I added, try to understand. This is external angle of this quadrilateral. This is external angle. Then this is the external angle, and this is the external angle. So I will add them, and their sum will be 360. So very simple, straightforward question. The diagram I made, it made little confused because on the wrong place I shaded it. So now this question. He says, let me reduce the size so you can see it more clearly. Okay. These are last questions. They are a little strange. And in the figure AFJD, AGHC, BGFE, BHID, and CIJE are straight lines. Find the sum of A, B, C, D, and E. Okay. So the strategy is very simple. Let me show you how I have done this. So the strategy is like this. Okay, let me show you. So the CGE, look at this, EGC, EGC. Let me show you. EGC. Can you see that triangle EGC? The E plus C plus EGC. Okay, that will be 180. In the same way, I will find out this E plus B plus EIB. That will be 180. Okay. Now we will take this angle. It will be A plus D plus AHD. Then I will take this angle F here. So this will be B plus D plus BFD. Then I will take this angle and it will be A plus C plus AJC. So if I will add these 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So these 5 angles, their sum will be 540 because they are making a pentagon. Okay. So I have written those 5E plus E plus CGE equals to 180. D plus B plus BFD equals to 180. C plus A plus AGC is equals to 180. AJC. E plus B plus EIB equals to 180. A plus B plus AHD is equals to 180. If you add all of them, the left sides will be added with each other. The right sides will be added with each other. So you will have 2A plus 2B plus 2C plus 2D plus 2E plus EGE plus BFD plus AJC plus EIB plus AHD equals to 900. So you add 180, 180, 180, 180, 180. So that will be 900. And 2A plus 2B plus 2C plus 2D plus 2E plus the sum of CGE plus BFD plus AJC plus EIB plus AHD is 540 because they are the internal angles, interior angles of a pentagon. So their sum will be 540. And so 540 equals to 90. So this 540 will go on the other side. So you will have 2A plus 2B plus 2C plus 2D plus 2E equals to 900 minus 540. So take the 2 common. So 2 bracket A plus B plus C plus D plus E bracket close equals to 360. So it will be A plus B plus C plus D plus E equals to 360 divided by 2. So the A, B, C, D, A plus B plus C plus D plus E equals to 180. So this is what. Oof. So this is a question number. I don't know what question that was. I just forgot. So that was the question number 17. Okay. So question number 18 coming up on your screen, and he says, let me reduce the size. You have to reduce the size. He says now you can see the whole question. The figure shows part of an n-sided polygon, where each side is produced. A1, A2, A3, A4, and up to AN are the interior angles of a polygon, where X1, X2, X1, X3, X4, and up to XN are the exterior angles. Show that the sum of the exterior angles of a polygon is 360. And given that the X1, X2, X3 plus X4 plus and up to Xn is equal to 360. This is what we have to show. So this angle, these are adjacent angles. This external angle, internal angle, they're adjacent to each other. So a1 plus x1 will be equals to 180. A2 plus x2, that will be 180. It's a straight line. A3 plus x3, that is 180, and x4 plus a4, that will also be 180, because these are the adjacent angles, adjacent external and internal angles, and so their sum is always 180. So a1 plus x1 is equals to 180, a2 plus x2 is equals to 180, a3 plus x3 is equals to 180, a4 plus x4 is equals to 180, and an plus xn is equals to 180. So add up all of them, so it will be a1 plus a2 plus a3 plus an, and plus x1 plus x2 plus x3 plus x4 plus xn, right? Close. So that will be equals to n times 180. So you will have the sum of the internal angles. We can find the sum of the internal angles, a1, a2, a3 plus up to an. The sum is given by this formula, 180 bracket n minus 2 bracket close, plus x1 f plus x2 plus x3 plus up to xn equals to 180n. So when you open this, it will become 180n minus 360. So plus x1 plus x2 plus x3 plus up to x4 xn equals to 180n. So bring these terms to the other side. So you will have x1 plus x2 plus x3 plus up to xn equals to 180n minus 180n plus 360. So 180n minus 180n will be cancelled with each other. So you are left with 360 only. So the x1 plus x2 plus x3 plus up to xn is equal to 360. It means the sum of the external angles is always 360. So this is how you will do this question. This is question number 18. So here we go. The figure shows the internal structure of a beehive made up of a regular hexagonal cells that can form tessellation with no overlap or gaps. Name other two regular polygons that can form tessellation and sketch their tessellations. Okay, so let me show you. The two other in the nature, remember my words, the tessellation means that the regular figures come touch with each other and there is no gap between them. That's tessellation. The tessellation is done by three regular figures, and one is the hexagons, which the diagram has shown, and the other ones are equilateral triangles and the squares. These are the three regular polygons which make perfect tessellation. So let me show you. Okay, so here we also have if you look at the floor of houses and shopping center, you will most probably notice that many of them are tile. The tiles used are usually in the shape of a square or a rectangle, a pattern formed by fitting together regular figures which completely cover a plane surface is called a tessellation. The following diagram shows how planes may be tessellated by equilateral triangles, squares, and regular hexagons. So these are the two diagrams which they asked you to make, and this diagram was already given in the question. So this is a tessellation found by equilateral triangles, and this is a tessellation found by squares, and this is a tessellation found by the regular hexagons. Okay. So, okay, now we are going to the next part. He says, why these regular polygons, why are these regular polygons able to form tessellation? What do you notice about their interior angles? When the tessellation is done, let me show you. You see, about this point, there are four interior angles of the square. So their sum will be 360. So here you have equilateral triangle 1, 2, 3, 4, 5. 1, 2, 3, one, two, three, four, five, six. So there are six equilateral triangles, their internal angles, and we can find, and their sum will be 360. Here in the hexagon, the each external and the interior angle of the hexagon is 120. So about this point, there are 1, 2, and 3. So 120 multiplied 3, that's 360. So these figures, they do tessellation because when you put them in touching each other, so about each point, the sum of the interior angles is 360. So no other figure can do that. For example, here here we have shown a regular pentagons. So when you put the regular pentagons, so there is a gap here. And the sum of these angles will be not 360. So because there is a gap. Okay. So these are not all, this is square and this is a different diagram. So only who do this tessellation thing? The others, and they cannot do that. Only these can do, because when you put them together, there is no gap between the when they tessellate. So the equilateral triangles, they do the tessellation, perfect tessellation, and squares and this regular hexagons. Show that there are no other regular polygons that can form tessellation. So I can show you, for example, here we have shown a pentagon. This cannot do the tessellation. If you only use this octagon, then this octagon cannot make tessellation because you have to put a square here to complete the tessellation. So the tessellation is only done by three regular figures, and that are equilateral triangles, squares, and hexagons. So suggest a reason why beehives are made up of regular hexagonal cells and not the other two regular polygons that can form tessellations too. Remember, I have searched on this, and I have seen some videos from the YouTube that why the bees make their hives in this hexagonal shapes. So I have came to know, and you can also watch the videos, that why the bees make their hive in the hexagonal shapes as hexagonal cells. The reason is the hexagonal, when they make the hexagon, regular hexagonal cells, uh, no space is wasted, and the and the maximum volume of the honey can be saved. And this structure is very strong. When they make the structure with these hexagons, no space is lost, and it can carry the largest possible volume of the honey, and it can also accommodate the larva and their queen and the honey, because this shape can contain the largest volume in the given space. So I think these are the few questions. That was the last question, question number 19 of this exercise. So, my dear students, today we have done exercise 11C from the book D1, and the name of the book is New Syllabus Mathematics 7th edition. And this is published by the Oxford University Press. And this exercise is also about the polygons, the interior angles, the exterior angles. And our course is only concerned with the convex polygons. And at the end, we have done a question on the tessellation also. I hope that you have enjoyed and you have learned something from this video if you have watched this video. And if you have liked this video, please share the link of this video onto your Facebook, onto your Instagram, and onto your Twitter. And please share the link of this video with your junior students, with your teachers. So whoever needs this video, please convey this video to them. It will help me to promote my channel. So thank you very much. I think it's a great blessing for me that I can make these videos and I can touch the students around the world and I can make their life a little easier. Thank you very much. Have a good day. God bless you all.